We usually see gold when it's already bright, polished, and sitting in a jewelry box. But to get to that beautiful end product, we have to start with something entirely different: gigantic blocks of solid rock. This diagram shows why getting gold is so difficult. Gold rarely sits neatly in loose, shiny nuggets. Instead, it is locked deep inside the rock's physical structure, surrounded by massive amounts of useless stone. These valuable gold particles are microscopic, scattered within that useless gray rock like tiny specks of pepper baked deep inside a potato. To reach those tiny specks, miners first have to gather millions of tons of that rock. One of the main ways they do this is through surface mining, which happens in vast open-air pits cut straight into the earth. Out in the open air, there is plenty of room to operate. Massive, heavy excavators and powerful explosives can rip huge chunks of earth out of the ground at once. A single piece of rock pulled from a surface mine can be up to 1,500 millimeters, or roughly 5 feet across. The other way miners reach the ore is by digging entirely underground, where both humans and heavy machinery have to navigate tight, dark tunnel networks. Down in those tight tunnels, there simply isn't room to handle massive boulders. Because the shafts dictate the space, the rocks pulled from underground max out at about 300 to 600 millimeters, or roughly 1 to 2 feet across. But whether the rock comes out of the earth 5 feet wide or 2 feet wide, miners face the exact same physical problem. The rock is a heavy, oversized container, and it is far too large to let anyone extract the microscopic gold trapped inside. To crack open those rock containers, they have to be transported from the dirt directly to the heavy machinery. Long, heavy-duty conveyor belts carry the raw boulders away from the mine site to begin a systematic breakdown. The first piece of machinery they meet is the primary crusher. Using enormous mechanical jaws, this machine forcefully bites into the giant boulders, snapping the solid stone and breaking it down into smaller, manageable chunks. This diagram shows the next step, a physical sorting stage called screening. It relies on a simple metal sieve. If a rock is smaller than the holes in the metal, it drops through. If it's bigger, it gets physically blocked. Mines use this sieve concept very strategically. Before a pile of rock even goes into a crusher, it hits a pre-screen. The rocks that are already small enough fall through the sieve and bypass the machine entirely. This keeps the crusher from getting clogged up with loose pebbles, keeping the whole process moving quickly. Then there is inspectional screening. After a rock leaves the jaws of the crusher, it must pass over another sieve. If a piece of rock was not crushed down enough to fit through the holes, it is rejected and sent on a conveyor belt right back to the start of the machine to be chewed up again. This screening process acts as a strict physical gateway. Absolutely no piece of rock is allowed to move deeper into the processing plant until it has been destroyed down to the correct size. But small pebbles still hide the gold. To finally expose it, the rock moves into a grinding machine. The goal here is to pulverize the rock into a fine powder until every single microscopic speck of gold is finally released from its stone cage and stands completely alone. Grinding solid stone into fine powder takes an incredible amount of electricity and mechanical wear. Because of this, miners follow a strict industry rule to save money: do more crushing and less grinding. They rely heavily on those metal crushing jaws, so the grinders only have to do the final finishing work. Once the rock is turned into a fine powder, it needs to be sorted again, but you can't use a metal screen to sort perfectly fine dust. The particles are so small that the holes would just clog up instantly. Instead, they use a process called classifying. Look at this diagram of a liquid tank to see how classifying works. Instead of sorting by physical size through a sieve, classifying sorts the rock powder by its weight and settling speed in liquid. When you drop the powder into water, the heavy, unground pieces of rock sink quickly to the bottom, while the perfectly fine dust floats gracefully in the water near the top. Large industrial machines, like spimal classifiers and hydrocyclones, use this exact liquid principle. By scooping up the fine dust that stays near the top of the water, they can pull out the perfectly ground material immediately, preventing the expensive grinding machines from wasting energy grinding dust that is already small enough. The rock has transitioned from a collection of boulders into a fine, flowing powder. In the beginning, we used massive metal jaws and sieves to handle the large size of the stones. But now that the particles are too small for any physical screen to catch, we rely on gravity and the way things sink in water. The process has shifted from solving a size problem to managing the weight of microscopic dust. Now that the rock is a perfectly fine, wet powder, the actual gold is completely exposed. By using specific chemical baths or bubbling air through the mixture, we can finally pull the freed gold away from the worthless rock dust. But removing the gold leaves a massive footprint behind. The plant is now left holding an enormous volume of leftover water mixed with thousands of tons of wet, useless rock dust. To deal with this, the plant pushes the wet mixture through an intense dewatering process. Through a combination of heavy filtering, forced mechanical concentration, and intense heat drying, the mine carefully squeezes the liquid out so the water can be safely recycled straight back into the factory's pipes. Once the water is drained, the wet mud that is left behind goes through a process called tailings dry stacking. The rock mud is concentrated until it reaches over 85% solid mass, turning it back into dry, stackable earth. This dry dust finds a second life in our communities. It is packed up and shipped to construction sites, where crews repurpose the earth to pave roads and mix building materials. A giant boulder pulled from the earth is methodically crushed, ground, and washed down to release a tiny, beautiful fraction of pure bullion. And the thousands of tons of useless rock that housed it? They get crushed down to build the exact infrastructure we drive on every single day.